Thank you for that introduction, and it's great to see so many people here this evening. Coral reefs are pretty amazing places. This is a video from the southern Great Barrier Reef taken in March last year. When you're imagining being out on the reef, some of you are probably thinking about swimming over a garden of corals through a cloud of fish. Others of you might be dreaming about going scuba diving. Some of you might simply enjoy messing about in boats. And some of you might be lamenting that one big fish that got away. Whatever you're thinking of, though, you're probably imagining that reefs look something like this, with crystal clear water, complex structure, and teeming with life. Unfortunately, on areas close to shore, close to human activities, we're seeing reduced water quality, such as you can see in this murky water of a reef on the inshore part of the central Great Barrier Reef. So what we do on land has an impact on the ocean and an impact on coral reefs. For decades, scientists have been studying these impacts to understand the sources and effects of pollutants on coral reefs. Unfortunately, there's a long list of products that have negative effects on reefs, including caffeine, shockingly, oil, nutrients and sediments, herbicides, insecticides, and heavy metals. So these products have a variety of different impacts on reef organisms. They can smother tissues. In this image, you can see dark brown, healthy coral tissue of a coral that's partially covered in a layer of fine sediment. These pollutants can cause higher levels of particles in seawater that block light penetration. This has a shading effect, and it can reduce photosynthesis and decrease the energy supply to the reef. Some of these pollutants can increase algal growth, and algae are competitors for corals. And others of these are toxins that cause damage to cells. So we know quite a lot about a long list of pollutants, but there's some other contaminants that might potentially impact reefs, including plastic and coal, and we currently know very little about those. There's around 275 million tonnes of plastic waste that's produced each year. That's a shocking number. About 13 million tonnes of that ends up in the ocean. Large plastic items, like the ones you can see washed up on this beach, can be deadly to whales, turtles, seabirds, because once they're eaten, they can't be digested and they block the animal's normal feeding processes. These large plastics also break down into smaller and smaller pieces called microplastics, and this is an image of some plastic fragments taken from a seawater sample on the central Great Barrier Reef. In addition, the world's two largest exporters of coal are also home to the world's most diverse and extensive coral reefs. This means that large quantities of coal are transported in close proximity to coral reefs. So if we want to manage the potential impacts of these contaminants, we need to understand what the effects of them are on our coral reef organisms, and that's what I'll talk about now. So this image here is showing you some plastic debris wrapped around a coral colony. So plastic doesn't just end up washed up on beaches or in the bellies of whales, it can also end up causing direct injury to corals on reefs. But as I mentioned, these plastics can break down into those smaller and smaller fragments called microplastics, and it's possible that corals and other organisms on the reef might directly ingest these microplastics. Recent experiments show that corals do indeed eat these microplastic particles. So in our experiments, corals have been eating up to 50 of these plastic microbeads per centimetre of coral tissue during a 3-hour feeding period. So that's of concern. But good news is at least one of these coral species we've been working on can spit these plastics back out again. So 4 days after these feeding experiments, we've recorded only 5 plastic fragments, a much lower number still remaining in the coral tissue. So that's good news because it means that potentially these plastics, once ingested, won't have a substantial impact on the subsequent feeding and digestion of those corals. They're able to expel them again afterwards. However, plastics can also have toxic effects because there's toxins like plasticizers in the plastics that can be released into the tissues and cause harm, and we don't yet know what the effects of those toxins are on corals. Fortunately, major shipping and spill incidents of coal are rare, but they can and do happen. In the event of a major coal spill incident, large fragments of coal are likely to remain quite close to the spill site. The finer particles, though, float, and it's likely that they can disperse away a long distance from the spill site following the ocean currents. Recent experiments exposing a range of different reef organisms to these fine coal particles have revealed that we do see detrimental effects. These images here, you can see a healthy coral, the light brown tissue of a healthy coral in clean seawater. In the middle, we have a coral exposed to moderate levels of coal. You can see coal sticking to the healthy tissue, and at the top is dead skeleton with coal particles stuck to it. At higher concentrations, after a 2-week exposure, there's no coral tissue left, and that coral skeleton is covered with these black coal particles. In these experiments, we also observed negative effects on fish, so fish grew slower when exposed to coal particles, and also negative effects on seagrass. Seagrass grew slower when they had coal particles stuck to their leaves. So these results are important because they help us to know what to do in the event of a coal spill. They help us to know which species are the most susceptible, and also what the timing of these impacts are. How quickly do we need to get out there and start cleaning up? So I'd like to acknowledge the following institutions and collaborators, particularly some of my awesome PhD students who've been involved in this work. Thank you.